us. So welcome to today's webinar. Thank you for joining us. Today's speaker is Tim Martel, and for those of you who might not know, Tim is the Standards and Certification Programme Manager for the AECB. Before that, he was a Passivhaus Designer for 10 years, and he's also been working for the AECB Retrofit courses for a similar amount of time. Tim is a specialist in embodied carbon and wrote the AECB's PHribbon software, and also does the training. Just a quick mention for the housekeeping today. Tim will talk for approximately 40 minutes.
Yeah, hopefully less, so we can get time for questions, yeah.
And as he said, that will be about all of the CarbonLite standards, leaving, 20 minutes or so at the end for questions. So if you could add any questions to the Q&A section, and then any comments or information sharing, links, etc., those can go in the chat. So welcome everybody, and welcome Tim.
Hello, good. So thank you very much for that introduction, Michelle. And so what I'd like to talk about today is really about how good design leads to the CarbonLite standards. And so I'm going to cover why use a standard, why would you want to use a standard, comparison to some of the similar standards, parts of the CarbonLite standard. And we're going to be looking at retrofit and also specifically step by step in, I'll deal with that right at the end because that's a special case. So I think right at the beginning, I want to bring the homeowners into it, and it could be the homeowner or the owner of the housing association, directors of that, or it could be whatever owners of a commercial building, there might be directors of that. And it's important to consider them because probably, well, that conversation about do we improve the building and what do we do, how do we approach that, that's a really important conversation. And it's easy to avoid having that conversation, but that's really the basis of all this looking at the standards, the presentation that I'm doing on standards. Well, that's where this may help, because in a conversation like that, probably what the direction it would go is, well, who do we trust and what approach do we have, and who do we align with? Well, there's all sorts of things that you could do. You've got the PAS 2035, which shows pretty much every possible option there could be. What it doesn't show you, though, is it doesn't actually, even though it does show you what doesn't work well together, it doesn't really collect things together into a direction of what could work really well together. It's a little bit more open and flexible than that. So it's for the retrofit coordinator to decide a package for that. But that's what the AECB standard does. It puts together a kind of a package, an ideal collection of things that work really well together. So if you weren't going with a standard, if you were just to put things together, ideas together from, say you go to a builder or an EWI specialist, and they say, we see you've got lots of stuff in your loft. We think the best thing for you might be to have EWI, and that's least intrusive. You don't have to move out. It doesn't require you to move out of the house or out of the rooms. It may be some inconvenience when the windows are done, if they're done as well. But essentially what we're talking about is wall insulation there. And that means there's still a fair bit of heat loss through the loft and the floor. And that's not a whole house approach. That's an incremental approach saying, well, we'll do this, but we don't really think about what else we might do in the future. The other problem is that being considered on its own, you're not actually thinking about having a whole house plan where you might consider what's the energy loss that we might be heading for in the future, and therefore what thickness of insulation should we be using in that wall insulation now. It's fine to just do one bit at a time, and in fact our step-by-step approach does do that, but what I'm saying is better to have a whole design, a whole strategy first, then you know how much wall insulation to put in, because actually part of the time when you're quoted for these kind of things, the builder or the specialist will know that you're looking for other quotes as well at the same time, and so they'll consider putting the least amount of insulation on unless you specify, and you won't be able to specify because you haven't got a whole house plan generally. So that's one thought there. What if you had loft insulation? What if you took out all the stuff out of the loft and you put in a higher platform, and then you could put in your insulation, and you could put all your belongings, your storage back up there? Well, that again is not actually a whole house idea. It's so we're dealing with one little component of that, and that's actually quite cost effective. You could do that almost in a couple of weekends, but you're still going to get a fair amount of heat loss through the walls and the floor, and that is a bit of a problem because it means that you're not actually really going to get a huge amount of improvement, even though for that part you're obviously going to lose a lot less heat. So what I'm saying is insulation is more effective all the way if you have it all the way around, and that's where a whole house plan, a whole strategy will come in, because what the AECB is talking about is having an energy target which requires you to have roof insulation, wall insulation, maybe floor insulation, and apart from that, you would have to consider the thermal bridges in the floor, and there's more at the wall-to-floor junction there. That's because actually I'm not showing the wall structure here because I've simplified the diagram, but where the wall structure meets the foundation, that's where you'd have a thermal bridge there, and also at the eaves here, and also at the window head and sill as well. So building fabric, I'm including windows in there as well as thermal bridges. And the idea is to keep a similar U values all the way around. So cavity wall, for example, typically 0.3. A new double glazed window is 1.1. So with a new double glazed window, you're literally losing 3 times the heat per square meter as you would a cavity wall, over 3 times, in fact. So that's why windows are also important. They have to be considered too. But more than that, also, you need to consider the ventilation. And you might say, oh, well, I don't have a ventilation strategy. I've just got windows. Well, you still have got a strategy, because the strategy there, according to the building regulations, is to start with a leaky box. And it has to be leaky. You can't have it any more airtight than the figures there, because that delivers part of the air requirement for the house, and the air requirement is needed for not only for you to breathe, but also for dealing with moisture, the various moisture sources that are in the house. And that's supplemented by trickle vents, which are all around the house, not just one side, but I'm showing them for simplicity on one side. And then you have also bathroom fan, kitchen fan, intermittent extract ventilation at these rates, which I've shown here. And to add to that, people should be opening their windows. They often don't, and that's part of the problem. So the ventilation strategy that you have for an existing building is really very variable. What it means is that you'll get the most ventilation in winter when it's windy, or windy days, because that's the time when most air will go through the trickle vents. And you have to keep on adjusting those according to how windy it is, or or opening windows and closing windows, and people forget, and that leads to quite poor indoor air quality, too much carbon dioxide building up, and too much VOCs as well. So what can you do about it? Well, great thing to do about it would be to adopt a standard where all these things, this collection of things, are all dealt with together, and you address all these issues and you put together all these aspects of good design. And so I've borrowed a slide from the Passivhaus Trust here and adapted it very slightly. So we've got the Passivhaus Standards, which are in pink on the side here, and we've got the CarbonLite Standards, which are in green, and then we have this graph of the existing housing stock, and you can see that this existing housing stock is quite poor, 130 kilowatt hours per meter squared per annum. Kilowatt hour, by the way, that's the unit that you get charged for on your energy bill. So per meter squared per annum makes it scalable to any size of building, and we get a standardized figure per year. So that's quite easy. So if we look at, first of all, we look at the retrofit standards there. We've got Enefit, that's 25 kilowatt hours per meter squared per annum. Enefit component method, it's not defined as such, not a hard limit as such, but practically speaking, it ends up around about 35, say. And the CarbonLite standard, we're at 50 in that little family of retrofit. Passivhaus new build, then that's 15 kilowatt hours per meter squared per annum. CarbonLite new build is 40, and then typical new build allowing for a performance gap is around about 80 or 90. So apart from the energy target, what are the differences between CarbonLite and Passivhaus Enefit? Well, it has to be said there's a lot in common, and retrofit, they both deal with retrofit and new build. They're both founded on good building physics, which protects the building fabric. That's half the reason it's there, and also for good indoor air quality. They have the same summer comfort standard for overheating risk. They both have a detailed QA process using photos and drawings to ensure the design intent is kept, and they both require PHribbon. But where they differ is that the emphasis for Passivhaus is really on it being a low energy standard. And there are two parts of that, two extra standards there, the Passivhaus Plus and Passivhaus Premium, that reward having extra PV. We don't do that in CarbonLite, where we like it to be energy efficient, healthy. Low carbon is more of a drive for us. Windows for Passivhaus are likely to be triple glazing. They're probably triple glazing for CarbonLite. Ventilation likely to be an MVH, well, it will be an MVHR for Passivhaus. It could also be an MEV for CarbonLite. The units are slightly different, the way we measure them. In CarbonLite, our standard is in air permeability, which is the UK standard. Then for low carbon heating, that's not actually required for Passivhaus, but the primary energy or primary energy renewable, P or PER criteria, that does favour having heat pumps, and it discourages direct electric, or doesn't actually rule against them. Whereas for CarbonLite, we do specify that you have to have a heat pump either now or later. One of our standards is that the step-by-step does actually specify having a heat pump straight away, and it has to be required for that. More on that later. And not only do we specify heat pumps, but we also want to ensure that they are installed efficiently. So we specify a maximum flow temperature of 50 degrees C, or best practice would be actually lower than that. And another thing we do for moisture issues is CarbonLite's the CarbonLite standard is certified through certifiers, and for retrofit, it would be a retrofit certifier. They have to take another special course. There are 2 courses that they could take on that, and that trains them in specifically moisture issues and all the other issues to do with retrofit. There are a lot more risks there. So that's another thing, another difference. So if we were to look at these standards, let's actually look at them in sections. There's a few people there enjoying their home. We have to remember it's people's home we're talking about here. So energy efficiency. For new build, 40, for retrofit, 50 kilowatt hours per meter squared round, as we were saying. And the air permeability, that's also part of the energy efficiency. So new build, 1.5 meters cubed per meter squared hour. Retrofit, it's 2. I'm going to talk about step 1. This is part of the step-by-step method. I'm going to talk about that a bit later rather than complicate the energy efficiency with that now. Another thing that we support is the building has to be comfortable. So as we were saying, the air permeability is for energy efficiency. Well, it's also for drafts. It also improves the comfort of the building. So same criteria there. But also the summer comfort of the building is important too. So that's less than 3% is the best practice, but there's a limit of 10. And because we've improved the air tightness of the building, we're now at a level where air can't just float through the building a little bit. That means that the infiltration is much less, and therefore we have to have a separate a separate ventilation system for good indoor air quality. So that can be MEV or MVHR. And the thing floating across the screen there, that was part of the heat pump system. That would be the tank that the heat pump system works with. And so for new build, you have to have a heat pump or a non-fossil fuel district heating system. And for retrofit, you have to have a heat pump either now or you could have it later. More on that, I'll describe more about that. And as I was saying, you have to have it, the heat pump must be installed efficiently, flow temperature less than 45 degrees, but 50 degrees aligns with Octopus energy, so we allow that too. And on that subject of being low carbon, why, well, low carbon, let's just look at the possibilities there. If we took a house, a semi-detached house, and considered how much carbon it creates from the gas boiler over 60 years, you'd have about 200 tons there over 60 years. And if you compare that with a CarbonLite full retrofit without an air source heat pump, because an air source heat pump could be installed later, and we don't specify how later, you'd get that. That would be half of it. And then for Enefit, which is the Passivhaus one, that would be lower again. But here's where the real difference is. Both of these are options without an air source heat pump. They both could have an air source heat pump too. If you installed an air source heat pump, then the step 1, the CarbonLite step 1, where you don't really have much insulation at all, there could be a little bit of insulation, but we'll look at the criteria for that a little bit later. That has a dramatic effect. So that on its own, just the heat pump on its own, has a huge effect. And the sooner the air source heat pump goes in, the better. Really, you could install the air source heat pump here if you were doing a full retrofit and you decided at B that you wanted to install the air source heat pump. That still has quite a good effect. That's a benefit installing it there. Even better would be to install the air source heat pump at the beginning, say at A. You could do the whole thing if you can afford to do it. The whole thing together, the air source heat pump and the full retrofit. That's the CarbonLite full retrofit. This orange line I've just shown with an air source heat pump. You could even just start with the air source heat pump at A. That's a step one, and then do a full retrofit later at C. And we come back to that in a later slide. That's quite an interesting scenario because we think that actually in the short term, people might be persuaded to start with their retrofit with the simpler solution, which is the air source heat pump. And then once they've had that for a little while, they can upgrade to the full retrofit. And there's a great carbon benefit in doing that. That's, as we can see, they all end up in the same kind of place. So the carbon benefit of doing that is that you don't lose anything. If carbon is the priority for you, then you don't lose anything by doing it that way. If thermal comfort is the priority for you, then you probably do the full retrofit first, as long as you could afford it. So another part of our standards is there's a QA process. And so for step one, you only require a few photos. There's this list here and some drawings as well. But for the other standards, you require a few more. That's all part of the process. And there are guidance documents for the certifiers to make sure that they understand the issues and they have a consolidated approach for all of that. And also so that they have guidance on what photos are appropriate and what to look for in the photos. The certificate looks like this. It's currently being redesigned at the moment. And just on the lower part of that, the energy efficiency side, healthy, I've just enlarged that section at the bottom. It talks about the things I've just been mentioning: energy efficiency, healthy, low carbon, reliable design. Reminds people of our principles. Here is the full criteria for all our standards, new build and retrofit and step by step. I won't dwell on this too much because it's quite a lot to take in, and you can look at it anytime you like on the AECB website. But what I will point out is that there are these green sections that go all the way across where you've got some commonality between all the various different standards. So MEV or MVHR, for example, this top one, the PHribbon, PHribbon modeling risk, overheating risk, 10%, 5% lower down. And so there's some commonality there. And you can see a progression of the air tightness as well, 5, 2, and then 1.5. So though, just looking at retrofit for a moment, I just want to clarify something about retrofit and introduce the step one. So the starting point probably would have been to have gas and radiators, a gas boiler and radiators. The way that the retrofit works is that the full retrofit works is you'd have a heat pump to replace the gas boiler. You'd have to resize the radiators, and then you'd also have the deeper fabric measures as well. There is some flexibility there, though, so you don't have to install the heat pump then. You could have it later. You could retain the existing and have it later as an optional stage. And if we just show those two together, you can see that actually they've got the same components. All we've done is move one stage to the end. So they've still all got the same parts. For step one, I'm just going to show what happens with step one, how this compares with that. With that, step one, all you do is you still have the heat pump and you still have the possible resizing of radiators. Well, very likely in step one, but the retrofit becomes a future plan. You don't have to implement it. And we recommend that you do, and we'd like you to, but you don't have to. So that's step one is really, I'll just explain that step one is part of our step-by-step method. So the method is called step-by-step. You can achieve the retrofit in a step-by-step way. In that step-by-step way, the minimum first step would be for you to have this step one solution, which is to have an air source heat pump. That's the minimum. And you can go further than that. We'll certify the house as soon as it's got meets that criteria of the step one. But you go further, and eventually the idea is you might get to the full standard. And you can take as many steps as you like to do that, and as much time as you like to do that. This other query here, this question here, that the AECB is promoting fabric first retrofit for many years. Why is there a step one which doesn't include deep fabric retrofit? Well, it just goes back to that slide really about being low carbon. It's a good low carbon interim measure, and it just demonstrated that it's actually quite effective. And we are interested in low carbon, so that's why we've got that. Low carbon energy is expensive and disruptive, so we have to deal with it on the demand side, not just the supply side as well. So just a summary on step one, it's low carbon. You install a heat pump. You're likely to need to resize the radiators. It's got to be comfortable and healthy. Air tightness is 5 instead of 2 for full retrofit. And energy efficiency, I haven't really mentioned this, but the heat pump costs must be the same or less than the previous heating system. So it can't be more effective. And that may require you to put in some insulation. That's also the driver behind a change in the size of the radiators. Because that also helps. Changing the size of the radiators also helps ensuring that's the case. And we use standardized costs from Ofgem. There's a pretty much automatic calculation to do that the Ofgem costs have to be updated every, 4 months. So we do think that just going back to that graph and this point I mentioned in an earlier graph, we do think step one and step two could follow on from each other. If you did a step one, a few years later, you could do a step two, and that has an impact on the carbon. We can see the embodied carbon in these steps, but they look really big on this graph. But actually, on the previous graph, we saw that they're not huge. So all this adds up to that rather flat curve that we saw at the bottom of the screen for full retrofit on the previous slide. And here's an idea of how that could work in practice. We thought that a step one could be adopted quite quickly, and some people might go for a full retrofit straight away. Other people may wait and just do the step one, and then later on, this second peak would be the people who initially did a step one carrying on and doing a full retrofit later when the heat pump was up for renewal. So just a recap on the standards then, it's pretty much about thermal fabric, walls, roof, floor, thermal bridges, air tightness and ventilation, MEV system or MVHR, and low carbon heating system. And here's a few examples of new build. Hazelmead here, there's 4 terraces like that. They look very similar, but these are different terraces. Another example, Ward Grove in Manchester, St Gabriel's Primary in Rugby, and a couple of examples of retrofit there. So I think what we'll do now is open it out to questions. I'll stop sharing my screen so I can see, I might be able to see some of the chat, any of your questions that have come in. But Michelle is going to ask any questions that have been made clear so far.
So we've got 3 questions so far.
Yeah.
The first one's from Andrew Allen. He says chimneys are a source of uncontrolled ventilation and heat loss. If you
Yeah.
reduce the ventilation by blocking it up, it reduces the heat loss, but also the ventilation. How do you go about measuring the heat loss from chimneys? Ideally, the chimney would be removed, insulation installed in its place in the attic, and MVHR installed if undertaking additional airtightness and insulation measures.
All right. So the question there is, how do you measure the heat loss from a chimney? Well, the chimney is as you say, it's a ventilation. It has an impact on the air tightness. So I have seen calculation methods for calculating the amount of heat that goes up through a chimney, and we've tried to implement it on 1 or 2 projects. I presume the reason is because you're wanting to compare before and after, and that will help you work out the improvement that you've got. It's all about the ventilation, so it'll have an effect on that. And we haven't got a specific method in the AECB, but you would use people's approximation that they'd had. We don't allow. I mean, because we have quite strict airtightness targets for the AECB, you wouldn't be allowed to keep an open chimney in the AECB building, not unless what you would be allowed to do is you would be able to have a sealed unit, a sealed boiler, stove in your lounge, say. So you could have that, but room sealed. I guess one of the other issues about having that, even an open flue or a room sealed one, would be that there's a requirement to have an air gap, some kind of ventilation gap in the wall, in order to allow the combustion process to draw air through into the fire, and that again leads to leakage, and you have to allow for that. And that's a bit of a problem. Whether it meets the target or not might do for step 1, but I doubt it for the others too. Okay. I think that's all I can say about that. We don't have a specific method of doing it.
Andrew also asks, if you install a heat pump first and retrofit later, would the heat pump not be very oversized and then perform inefficiently after the retrofit upgrades have been undertaken?
That's an interesting question. And let's share the screen again. The chicken there is to illustrate that you might feel as if you're kind of falling flat on your face. Will the heat pump make it inefficient? In other words, step 1, lock-in. And this is quite a common question. So the question is, if you have a large air source heat pump, is it going to make you a bit stuck, because you're then stuck with a large air source heat pump, and it actually it makes it inefficient for your next retrofit, but maybe even prevents you from doing the next retrofit, because you might think, well, there's no point in doing another retrofit because my heat pump would be oversized, can't afford to change that too. But no, we've had our specialists look at this, and they said that the larger radiators for step 1 allows you to reduce the temperature for full retrofit. That allows you to have the that allows you to have a very low temperature for the heat pump, which allows you to make it even more efficient. You have to also remember that air source heat pumps very rarely work at their full capacity. because their full capacity will only be will be the coldest day of the year, peak demand on that time. So they can quite easily modulate down to 25 to 30%. So when the weather is warmer, the heat pump won't become more efficient than in cold weather. And the other thing you can do is you can just reduce the number of heating hours in warmer weather. And if you do that in a sensible way, reducing those hours, you could reduce it to off-peak rates, the times that you have off-peak rates. So that's another advantage. So our expert, Alan Clark, considered that it's not actually a real issue having a larger air source heat pump. Obviously, it will be better in the long run, but it shouldn't stop you from doing the retrofit.
Okay, thank you. Anonymous attendee has asked, can you certify CarbonLite for individual flats? My understanding is that you cannot do this for Enefit. It requires the full block to be certified.
I think we have the option of doing either the building or the flat, and I'm not certain about that. So I'd like to check that, but I think you have the option of either.
Okay, well, if anonymous attendee wanted to email
us and we'll clarify that.
We could clarify that, couldn't we? Okay. Liam Acton has asked, what skills will be needed in the construction industry to meet these annual targets? Where are the skills shortages likely to be and when? And what roles do you recommend for people moving into the sector? Quite a lot there to unpack.
Well, obviously we need people trained in the various retrofit methods. We need people to be able to do wall insulation, internal wall insulation, external wall insulation, floor insulation, windows. Obviously, we need all that. There's a fair amount of that already. We also need people to be trained in overseeing that whole process. That's the CarbonLite certifiers. We have around about 50 of those already. You can certify your own project. So 50 it sounds, well, it's more than the number of Passivhaus certifiers, but it's not that many really in terms of being able to certify your own project, because they're more in line with actual the modelers. They do the modeling and they certify it as well. You can have separate modelers that would require you to have a separate to pay them separately. So it's probably going to be the certifier who does the modeling as well, quite likely, and it might well be in-house. So I would say that's a good area to get into. You can look at our courses and our certifier requirements and see if that fits in with your current experience. Other than that, as I said, the various insulation methods or the MVHR specialisms in that, really.
So do we know what the shortages are?
Oh, shortages.
Yeah.
I don't know. No, that would be, it would be good to find out what the shortages were. I don't really know. I'm sure it'll be regional anyway, in any case.
Yeah, we'll perhaps have a look into that. Dr. Jamal Alabid has asked, what should be considered when improving fabric to avoid frost damage?
Aha, frost damage. Right. Okay. Well, frost damage, I think you're talking about spalling in brickwork. And that happens when the brick is wet. So near the ground, I mean, this isn't specifically an issue to do with standards, although in the context of thinking about the whole building and thinking about something that's going to work, I think what our certifiers would do, and the general approach for the whole building, is that you would want to have a method, you would want to consider an approach that was actually suitable for a building to reduce problems like that. And so spalling generally happens because there is moisture in the brick, and that freezes, and that causes the front face of the brick to be lost. And in order to, you could prevent that by reducing the moisture content of the brick. There's some brick creams that we would recommend for internal insulation. So if you had internal insulation, then the external face of the building remains the same. And then that external face could have quite a high moisture content. It could be, depending on the type of building, if it's an old building, these can get a bit more complicated. But if there's rising damp coming up through the wall, or I imagine you're talking about close to ground level, if there's rising damp, then that could eventually lead to frost damage, because the extra moisture content would freeze, and that would be what's happening there. So reducing that by a brick cream, or stone if it's stone cream if it's stone, similar kind of approach. Perhaps, I mean, this is an idea. You probably should have an assessor, some kind of expert, to have a look at your building rather than take general advice. I haven't even seen the building, so but that's the sort of thing you might do. And if you were to retrofit, then it might actually cease to be an issue in retrofit. Perhaps you're retrofitting on the outside, and the whole external fabric of the building is now protected, to protect it from external rain load, protect it from, perhaps you're putting in a retrospective DPC, so that might be also part of the solution too. Lots of different things. That's quite a specific example, a specific question rather, and we need to look at your building.
Thank you, Tim. Well, we don't have any more questions at the moment, unless anybody wants to get some in, because we've still got some time left of the webinar. You did go through your slides quite quick there, Tim.
Oh, well, just in case we had a lot of questions.
You never know. Sometimes we get lots, and then other times we get fewer, so you can never tell.
I'll just see then, well, in that case, we just a moment, I'll just see if perhaps there's another question I anticipated. I could talk about, if I just share the slides again. Let's, I could talk for a moment about the boiler upgrade scheme, because if you're talking about getting a new air source heat pump, there is a boiler upgrade scheme. We need to think about MCS, because the boiler upgrade scheme works by, they'll give you 7,500 off the cost of the installation of an air source heat pump or ground source heat pump. But in order to do that, it has to be installed through a certified MCS installer, and they claim the money. They claim the 7,500, and that affects what they charge you. So they'll still charge you something, but it'll be substantially less, because they've already got that money from the government. And so worth doing. And in order to get that information, they have to do, in order for the MCS installer to install it, they have to do an energy calculation. And a great thing about the work that we're doing now is that we can hand over information to them from the energy calculation of the building. So we would, in the actual process of certification of a new build, or well, let's see, wouldn't be a new build. If it was a a retrofit, then the calculation, there's a part of the calculation where it shows that the U values and information that the MCS installer would need, and that gets passed on to them so that they have an effective or accurate model of the energy loss of the building, so can install the correctly sized heat pump for it. That's where we link into them. And a few things else we could say. The EPC must have been issued over the last 10 years. There's a few extra things on there to say about the boiler upgrade scheme. So leave you to read that. Well, there's a few conditions on there as well. Maybe I'll go on to another slide as well, actually. There is another thing to say. The calculations that I mentioned about Ofgem calculations, these are put into our calculations. This is an extract from our certification spreadsheet. So Ofgem figures go in there into these yellow cells, and then it calculates the cost. So the question probably, this is answering the question, how do you calculate whether something is less cost now than it would have been before? And the answer is, well, you put the Ofgem prices in there. Well, it already have the Ofgem prices in there, and the spreadsheet just calculates it for you. You don't really have to do anything. So as long as you've done the PHribbon, this interrogates the PHribbon, takes the information from that, and then passes it into this calculation, which gives you the answer. And the answer appears as a tick or not a tick on the certificate. So if you don't get the tick on the certificate, then it hasn't quite passed.
So if someone hasn't passed, would you give them recommendations for measures that they could take to enable them to get that tick?
Well, exactly. If it doesn't quite pass, then they'll know exactly what they didn't quite pass on, and they could think through the design again. And that's the great thing about PHribbon. It allows you to do all of this on a desktop study before you actually build the building. So you can think it through. If it doesn't pass, then you go back to your PHribbon, improve things a little bit. If it didn't pass, then you might need to put in some insulation. It depends on your approach. You could resize the radiators again, and resizing the radiators means that you could run the heat pump at a lower temperature. Running the heat pump at a lower temperature is modeled in PHribbon. It allows you to, PHribbon is quite an amazing tool, it allows you to see what the effect of that would be. And because of the increase in coefficient of performance, well, really the seasonal coefficient of performance, SCOP, because of the increase in efficiency of that, then you might then pass. If you don't still pass on that, then you can reassess again. So there we go.
Thank you. We've had another question come in from Andrew Allen. Thanks, Andrew. A question I've come across many times is, how do you prepare a retrofit so that you don't sabotage a future upgrade? For example, if you want to improve your windows and undertake EWI but can't afford to do both, one can either decide to do a poor installation, such as upgrading the windows and then adding EWI afterwards, which means the windows won't be in the insulation zone. Alternatively, one would have to resort to disrupting either the EWI later or the windows. What would you do in this scenario?
Well, what I'd recommend is doing it at the same time. But of course, I think what you're saying is you can't afford to do them at the same time. Yeah. It's a bit difficult. But they should be part of the same process. Ideally, they'd be part of the same process. If it's IWI, if it's internal wall insulation, I think you were talking about EWI there, weren't you?
It says EWI here, yes.
Okay, EWI. Well, I mean, they can be, you can allow for it. I mean, this is more of a technical question for the EWI installer, really. You can allow for the EWI, the windows to be installed a little bit later. It's messy, as you say, it's messy. There is no real great solution there. You just have to work it through. If you can do it at the same time, well, actually, perhaps the solution would be, why don't you do the front of the house with the windows, EWI and the windows at the same time? Then when you can afford it, assuming that being able to afford it was the limitation, what about doing the back of the house another time when you can afford it and do both at the same time? Both is a lot neater, as you say. It's you don't get a very good solution doing it either way, the other way.
Dr. Jamal Alabid has asked, resizing radiators when installing heat pump, is that increasing or reducing the size of the radiators?
Increasing.
And he says, I guess you need to resize them again after fabric improvement.
You could potentially take some away, yeah, and reduce them. So that you have to weigh up that cost of resizing the radiators, yes. But the cost of resizing radiators is probably not going to be as much as you would spend on insulation. You know, it's an option for you. So if you don't want to spend money on insulation doing full retrofit, then you can spend a little bit on resizing the radiators, and that will get you to the step 1 retrofit. Yeah, that would help you get to that level. But you don't have to do it that way. If you didn't want to resize any of the radiators at all, you could do it with insulation instead. And this question about, it was a very interesting point that you made there, actually. This question was really about locking in measures, and that's a very important topic. Locking in things for the future, where you, for example, if you had your external wall insulation and you had it installed, say, by a local builder, and it turned out it was too thin, you might say, well, let's put some external wall insulation, and we won't really care about whether that fits into a whole house plan. We'll just put it on. Well, it might be that it doesn't fit into the whole house plan, and then when you come to try to reach net zero or a full retrofit, you have to take that off. So all the AECB measures are designed to work through a system in which you don't have any regrets about any of it. They all work together. So the step 1 leads very, very easily into a full retrofit. There's nothing that has to be undone. That's not the case with all retrofits. Sometimes, if you're not careful, you may have to undo some things. If you've put in external wall insulation, which is too thin, it's probably not cost effective to replace it within, well, the life of the insulation, 20, 30 years. That's called lock-in. So you've locked in a low performance, and that's why you should think about putting the maximum insulation on straight away. This is this lock-in principle. So it's better to do a retrofit in stages. Even if you can't afford to do the full retrofit, then it's better to do, say, the front of the building to the full insulation thickness that you need, even though that might mean that you don't have insulation on the back of the building. Better to do it the level that you actually need, rather than leave it to a later stage, because it won't be cost effective to do it that way. Right. So very, very interesting question and very good point. And that's why we have people trained to make sure that you are thinking about the future. And that's why we also have, in step 1, we also include looking at the whole retrofitted building, we require you to model that extra process so you know what's going to happen in the future, and you don't end up doing something which you might have wanted to avoid. So
Okay.
great question.
We've got a flurry of questions now,
Oh, good.
which I thought would happen just with 3 minutes left. So Nigel Banks asks, where does solar PV, batteries and/or smart controls fit in with our standards and steps?
Aha. Well, that's an interesting question too. It doesn't actually. That's not part of the AECB standards. That's an approach, and it's a very interesting competing approach. And I think you're talking about the system where you have no bills approach, and that's an alternative, and people can look into that. We don't actually require that. It's not. We don't require people to have PV. That's not part of our thinking at all. That's part of the Passivhaus thinking, as I mentioned earlier on. They give a benefit for having PV. We don't. Having a battery, likewise, is not part of our thinking either. So what we do, and there are alternative methods. We're not saying we've got the only retrofit solution. There are all alternatives. But what we do is we look at the measures which we think are most useful to the building occupants. And we think that having an insulated building that has a huge number of knock-on benefits for the building occupiers, not just, I mean, if the cost of it was the same, and it probably isn't, but if the cost of it were the same, then having all these extra benefits of an insulated house, and good air quality and all these other things, huge health benefits for the building owners, building occupiers, really. So you take your choice. Lots of different solutions.
Amy Somerville asks, are there any case studies where CarbonLite has been used for social housing retrofit? And has there been any analysis on the cost implications compared to a PAS approach?
Probably. I don't have that information readily to hand, but there probably has, and it would be interesting to see that. I can't answer that at the moment because I haven't got that information, but we could talk to our certifiers. We've got about 50 and I can't talk to them all and find out what they're doing. It's difficult to keep track of what they're doing. So we could ask. If you contact me, tim@aecb.net, we'll ask our certifiers, see if they've got any information on that.
I'll just pop your email address in the chat.
Oh, yes, so good, thank you.
People can see that. That's a good idea. Andrew Allen says he was refused a heat pump due to there not being a high temperature heat pump available on the database. The only option is to change the windows, very expensive, or add EWI, also expensive. And that seems the wrong approach, he says. If you install an HT heat pump, then the flow temp would be higher, which would significantly reduce the COP. It seems short-sighted. A better solution might be to upsize the emitters, keep the flow temp as low as possible, and optimize the system with weather compensation. What do you think to that, Tim?
Oh, I was going to say, you seem to have answered your own question. We had our experts, service engineers, look at this, and our expert there is, well, Alan Clark is one of them. He's a services engineer with a lot of expertise. We rely on him for a lot of our advice at the AECB. And he said that even though there are high temperature heat pumps available, which claim to work at high temperature, they all work better if they're allowed to work at a lower temperature. And that's why we encourage this temperature limit, 50 degrees or ideally less than 45 degrees. So, as you say, increasing the size of the emitters allows you to have a lower temperature. They all work because of the principle of a heat pump. Even if they do work at high temperature, they're always going to work better at a low temperature. And the the lower temperature means that you can have a better coefficient of performance, which, as you say, leads to a better result. So that is going to give you a solution which doesn't require you to put on the, well, it depends what you're talking about here. If you're talking about a full retrofit, then our retrofit standard, you would have to put on insulation for that as well. If you're talking about only the step one, then you can avoid having most of the insulation for that. You might have to upgrade, say, loft insulation or cavity wall insulation if you didn't have it, but it should be done within the context of the whole calculation. You can look at a building, you can look at the PHribbon result, the Passivhaus planning package, and assess what the best route forward is. When you've got the data, I wouldn't be able to say very much without actually looking at that.
Okay, thank you. We've just gone over 1 o'clock, so we'll just squeeze in one last question if that's okay, Tim.
Sure. Yeah.
Jack Morwood has asked, is there a requirement to use Passivhaus certified components to achieve building certification?
No.
I understand that there isn't, so the AECB standard could allow a lot more flexibility with the supply chain compared to the house standard.
Well, the Passivhaus standard doesn't actually require you to use Passivhaus components for a lot of things either. They give a margin. What they do is they give Passivhaus components, Passivhaus certified MVHR, for example. You have a percentage because the way that the Passivhaus Institute tests MVHRs, they have a certified MVHR will give the figure directly that you need to use in PHribbon, the figure that you actually want from a manufacturer. But the manufacturers don't give that figure. So if you have to take their figure, then you have to apply a correction to it. That's what the Passivhaus Institute's figures are all about. But yeah, as you say, you don't have to actually, you don't have to have Passivhaus certified components for AECB. No.
Okay.
I don't know what the situation is. I think we still do apply that 12% rule though for MVHRs. The efficiency of an MVHR, if it's a Passivhaus one, would need to check on that. And the certifiers, well, the certifier would know the answer to that. They're the ones checking the calculation.
Brilliant, thank you. Thanks for your time today, Tim, and thanks to everybody for coming along to today's webinar. This webinar will be available to view probably early next week on our website for those who missed out. And thanks ever so much for coming, everybody.
Thank you.